Hi, Assalamu alaikum. My name is Ashir, and I am presenting my own project which I have done in my bachelor's under the supervision of Dr. Suleiman Mazhar, which is the project name is Big Data Applications and Analysis of Diabetic Retinopathy using AI-based solutions. So I am the only member in the group presenting the presentation. So my course name is the Research Methodology, and my supervisor during that project was Dr. Suleiman Mazhar, who is being engaged in the robotics labs at ITU. So the problem statement of this project includes the classification of the diabetic retinopathic infected eye image from the normal image. So as we can see that diabetic retinopathy is a prevalent disease worldwide. As of 2013 there were 282 million patients of diabetes. So by 2035 there will be approximate 592 million diabetic patients. So 282 patients out of every 17 million patients diabetes patients are of diabetic retinopathy. So 21 million were diabetic macular edema patients. So the prevalence of diabetic retinopathy in Pakistan is substantially high. Regular screening needs to be implemented for early diagnosis of diabetic retinopathy. So in Pakistan, there is no such work, high level screening on wide scale. No work is done on it, but the European countries are really serious about it, and even in UK they have the world countrywide diabetic retinopathy screening. So as we know that diabetic retinopathy is hard to diagnose, so there are no early symptoms of this disease. So it is necessary for diabetic patients to undergo screening process. So screening is necessary for the people of diabetes, and it's a responsibility of the government to do that, and the big private firms also can do that. So screening helps in identification of disease earlier. There are several methods for screening all over the world, which may be effective screening or ineffective screening, depend upon the methods they are using. So there are several methods of treatment for diabetic retinopathy. First one is laser photocoagulation treatment. The second one is light mask treatment using special light therapy, and the third one is anti-VEGF, anti-vascular endothelial growth factor eye injections, which are being used on the eye. So the fourth one and the last one I have read in my literature review was about the removal of parts of vitreous gel in the eye. So the work being done for having good solutions related to this disease detection are as follows. As we can see that the diabetic retinal executes in digital color images, so they convert it to RGB images and then use the spot vector machine to train the models for the further prediction and classification purpose for getting the accurate results. So the second one includes the decision support system for the detection of diabetic retinopathy using smartphones. This method is named as ophthalmoscope. They used it on the smartphones, and then they detected the uh, patient eye. And the third method we have is web-based platform, which is a centralized database, and the researchers, academic as well as industrial researchers use this platform to get the required data and analyze accordingly and make well well equipped models which will give us high precision, recall, and the accuracy. So after reading this all, I have made my I have come to the concluded solution. As you can see that I am using a peak view lens and attached it to the smartphone camera. As you can see in those images, this is a peak view lens and how it is attached with the camera of the Android phone, and how we are taking the image of the person having the diabetic retinopathy to check whether it has or not. So The um, the phone is using the application which is attached with the lens named as peak retina camera, so it magnifies the contrast, coloring, brightness, and the clarity of the image being taken. So the eye is being diluted before the capturing of the image, and then the image is saved into the gallery, and then we can use different IoT devices, ways, and transfer the data of the phone to the desktop based application. So I use MATLAB scripting for the for the purpose of machine learning part, and then there I pre-process it the data and did the edge detection, and from that I have extracted the features and then optimized the features based on the error uh, in the model. But that means that I am minimizing the loss function value so that I can get the higher accuracy. So in the model I have used knife biased for the classification of the normal image of a normal person from the patient images of diabetic retinopathy. Then then for the implementation of the pre-processing part, I have converted the normal images to different color spaces. I have tested, for example, the RGB space, grayscale space, CMYK, etc. So the grayscale space gives the best results, and also tried separate channels but it didn't work for these channel images. So the applied contrast limit histogram equalization CLAHE, which proved to be better than adaptive histogram equalization AHE, as it is computing histograms on pixel level as compared to the whole image histogram in case of AHE. To get the I have done this to get the features, to extract the features. So the dataset I took was from Kaggle repository, and then I applied different filters like Gaussian filters, Sobel filter, Cannes, and Previtt for edge detection. Uh, and the edge detection with the Cannes gave very good results as compared to the other techniques and gives me the best features I can get through. So in edge detection, we get the image matrix, and then we will convert the matrix to a vector row, and then we combine all the rows, and each row is representing the image, and the column will represent a feature, and this combination will make a new matrix which will be used in principal component analysis, which we will discuss in further detail. So now I am presenting the uh, uh, so now I am presenting the visual representation of the pre-processing and the feature extraction. So here we can see the given image, and after applying CLAHE, the image becomes this clear, and after applying canny edge detection, so there I have got the feature of all the features that are important for learning in that image. As we know, in the principal componental analysis, goal is to find a new set of dimensions that better captures the variability of data. For example, first dimension has more variability, second dimension has remaining but less than the first, which is it covered, and the third has less than second, and this goes on. And it also identifies strongest patterns in the data, so it can be used as pattern finding technique. It makes data low dimensional, so it's a reduction of the dimensionality we have been doing here, which can be easily be applied to techniques which don't work well with high dimensional data. So as we can see, it takes a M by N matrix. Rows represent the data objects, columns are attributes. In our case, each row is representing an image vector. Then the PC algorithm will apply covariance on the input matrix. After this, the algorithm will do eigenvalue analysis of the covariance matrix, which produces a positive semi-defined definite matrix having non-negative eigenvalues. The new attributes we get after the analysis of principal components. So now the basis of naive which we are using in the model are with the Bayesian theorem. So the theorem states as the following clauses. So the first clause is attributes as is that is denoted by x showing matrix rows, i.e. image vector. So the class variable is represented as y showing matrix columns. So x is represented as an image and y is the output class representing that input x. So the probabilistic relation is given as p y given x. So during training, we need to learn the probabilities for every combination of x and y based on information getting from training data. Then we do testing on test record x bar, which can be classified by finding class y bar that maximizes the posterior probability or conditional probability of p y bar given x bar. So our naive Bayes classifier estimates the class conditional probability by assuming that the attributes are conditionally independent given the class label y. The conditional independence assumption can be formally stated as follows. So the formula is given in the equation 5.12 where each attribute set x is equal to x1, x2 up to xd consists of d attributes. So here we can see the working of the naive Bayes classifier. With the conditional independence assumption, instead of computing the class conditional probability for every combination of x, we only have to estimate the conditional probability of each xi given y. The latter approach is more practical because it doesn't require a very large training set to obtain a good estimate of the probability. So to classify a test record, the naive Bayes classifier computes the posterior probability for each class y. So here we can see that theory in that example of the formula 5.15. So now our future work includes the following points. So I am taking data set from my uncle who is an eye specialist in UK. He agreed upon providing me for real-time data for as much data as he could arrange for me as images are being stored in those countries for research purposes. The data will be useful in proving the accuracy of my model. So the choice of model and the percentage of data being trained will play an important role in getting the improved accuracy, for example, in using SVM and naive Bayes. So we will use the matrix provided by the image vectors and place it to the principal components analysis, which will do the feature optimization, and we can select our range of features to be used in machine learning. So for machine learning, we will be focused on naive Bayes as suggested by a paper referenced at 9 number. So here we are seeing the references of the papers we have read in our throughout the research. So these are total 15 papers and some data sets cited in the reference portion. So I am thankful to Dr. Salman Mother for guiding me throughout the project and Dr. Taimoor Bakshi for giving me the privilege to present my work in front of everyone. So thank you so much, sir, for this privilege. Allah Hafiz.